For this problem, we are looking for a pair of integers, or maybe more than one pair of integers, whose product of two consecutive odd integers is 35. So first, a quick discussion on odd integers. So consecutive integers, for example, 3, 4, or -2, -1, can be expressed as x and x plus 1. Consecutive even integers, for example, 2 and 4, or -8, -6, can be expressed as x and x plus 2. Notice the 2 and 4. 4 is 2 more than 2, so you add 2 to get to the next consecutive even integer. Now, consecutive odd integers, like 3 and 5, or -7, -5. How far apart is 3 and 5? Well, 3 plus 2 is 5. So again, you can represent these as x and x plus 2. This might cause some confusion because you see consecutive odd, and yet it's still plus 2, like the consecutive evens. But that's because 2 and 4 differ by 2, as does 3 and 5. So to get to the next consecutive even or odd, you have to add 2 to the one before it. So we will have x and x plus 2 for our odd integers, consecutive odd integers. We're going to use x and x plus 2. Now that we have that in place, notice that this says the product. So we're going to multiply these x and this x plus 2. The product is 35. So we have the first one, x times the second one, x plus 2. The product is 35. It is important to keep this parenthesis around the second one. Anytime you have a binomial, two terms, and you are doing operations with that, like multiplication, division, subtraction, addition, it's best and almost always necessary to use parentheses around it to keep it together. Okay, so now we have a model, an equation for this situation. It's the product of two odd integers, and by the way, this could be also even integers, equals 35. No two even integers would multiply to be 35, so we'll find for sure odd values when we finish this. Let's get some space and solve this. Okay, to begin, we would first distribute through parentheses to get us x squared plus 2x equals 35. We would then move everything to one side, so we'd subtract 35. And we have x squared plus 2x minus 35 equals 0. You put the 1 in front of the x squared. So we need to do 1 times -35. That's -35. And we want to break this up. I only know 5s and 7s. And 35 and 1, those are the only choices. But we want to add these up to a positive 2. And so there's a clear choice, -5 and plus 7. Okay, so we take our x squared, we take the 2x and rewrite that as -5x and plus 7x minus 35 equals 0. We can now factor by grouping. Factor out the x, we have x minus 5, plus factor out the 7, and we have x minus 5. Make some more space. We can then factor out the x minus 5 binomial factor, leaving us an x plus 7. And the product of two factors equals 0 is only true if one of those, could be this one, or could be this one of those has to equal 0. We can then solve each of these separate equations to get our two answers of x equals 5, x equals -7. But wait, we need to find two odd consecutive integers. And we represented them as x and x plus 1. Sorry, x plus 2. So if x equals 5, then x plus 2 would be 7. That's one pair of odd consecutive integers whose product is 35. But if x is -7, -7 plus 2 is -5. And that is a second pair of consecutive odd integers whose product is 35. So we have found two answers, 5, 7 and -7, 5. And that completes this question.